Hi everyone, my name is Xiaodong Chen. I'm a product manager of Oracle Database Tools. Welcome to Oracle Database World. Today, I would like to talk to you about how to build a modern application using Oracle REST Data Service. And the agenda is quite simple. First, I will give an introduction of Oracle REST Data Service. Then, I would like to walk you through some new features that we launched in 2021. Next, I would like to give you a demo of how to create a REST service on Autonomous Database. Last but not least is the conclusion. ORDS started out as a web listener for database and for PL/SQL APIs. So if you have a procedure or a function that will result in HTML being printed as a return, ORDS will take that HTML and bring it back to your client. And it also allows you to call those programs via HTTP. Now, ORDS has evolved to be more than just a web gateway for PL/SQL. We now allow you to, host full RESTful web service, for your Oracle databases. Basically, if you want to perform a put, get, post, delete actions in and out of your database, Oracle REST Data Service make it simple and possible. So we now have a SQL Developer web interface. So if you want to query, tune, or manage your database, you can do that all via your browser. And that's all delivered via ORDS. ORDS also allow you to publish a database management API, not only for your tables, not for your PL/SQL, but APIs that helps you to manage the database itself. And finally, we provide SODA for REST. So if you want to manage document or collections in Oracle database, ORDS make that possible too. So, if you would like to know more about those features, you can go to oracle.com/rest. We'll provide a very comprehensive documentation and live labs for you to try out those features. So the first example I'm going to give you is the PL/SQL web listener, which is also the most traditional and foundational feature of ORDS. On the web listener, that's most likely gonna be surfaced if you're Application Express or Oracle Apex customer. You should also be aware that Mode PL/SQL has officially been deprecated and unsupported. So if you want to have a supported running web infrastructure out of the database, that needs to be done via ORDS. If you're a Mod PL/SQL client, we also provide full documentation of the migration process towards as well on our official website. For the RESTful web service, you can take a table or an existing stored procedure and say, I want there to be a set of HTTP endpoints that can be called to interact and access these objects. We can do that using the auto-REST feature. Very, very low code. It's just one PL/SQL API call to enable this. You remain in complete control and publish your own RESTful web service that are built on your PL/SQL and your SQL. The response that ORDS provides take care of the things like paging results, so you don't overwhelm your web clients with the millions of rows to return on page one. So we can automatically take the output and your stored procedures and wrap them in a JSON document, and will provide proper HTTP response. So get the right status code to get all the links you would like to expect. The services are defined in schema in the database. So whatever these services can do are controlled by security and response definition. You have applied on schemas, so you can't publish a REST API service that can drop the database if that user does not have the ability to do that. Other than that, you can use Liquibase and SQLCL to capture version and deploy the Oracle database schema. To build your RESTful web service, you can do that via a classic interface such as SQL Developer Desktop or Bash via our command line interface like SQLCL. You can use PL/SQL API, and now we have a full REST dev interface in both Application Express and SQL Dev Web. Oracle REST Data Service is a core feature in Autonomous. So, any Autonomous database that spins up is going to have ORDS here. And it's going to make SQL Developer Web available. So as for, Application Express. But you can also run ORDS anywhere you like for any of your Oracle database, wherever it is. Here is just an example of RESTful web service. Instead of saying select star from employees or department ID equals to 50, I can just do a get on HR/employee/ query parameters department ID equals to 50. And ORS will take that and wrap that to a proper SQL statement. And then we can get the results, put it back down to the client as JSON, and has that paged for you. And we also provide links to each of those individual records. So if you're building a web application on top of this table, your fancy user interface can just take advantage of these existing endpoints. And navigation is made very easy with all those links as well. These are of course secured, so you can't just give all those kind of links to anyone and then they can start using them. They need to be of course authenticated and authorized. So the endpoints are secured with privilege. You're welcome to use OAuth to protect all those kind of endpoints. And if you don't have the right role, then you don't get in touch with those things so that your data remains safe. This is an example of our browser-based database clients where you will be able to directly interact with your database. You can do query, you can do tuning, you can do any kind of management actions on this web browser interface. Next is for the database management REST APIs. So this is for managing and monitoring your database itself through over 500 endpoints. That makes different kind of APIs and different data dictionary views available for you via HTTPS. So here's an example of me kicking off a data pump export job by just doing a very simple post to the appropriate endpoint and passing the data pump parameters via the HTTP post body, and in this case as a JSON document. All of those features I mentioned earlier are included with our Oracle database license, even if it's a free database, or it supports both our classic architecture like single instance, single database, and also our multi-tenant architecture. So if you have a container with 200 pluggable databases, you can install ORS once and have it available for all of your PDBs. ORS is developed and maintained by the database team and for the database team. So as new database features come in, we're there to build the APIs and front-end toolings around those. Or it's like many of other Oracle database tools project, we had a quarterly release. So every 3 months, you should be able to see the updates for both cloud and on-prem version. All right. So there have been many remote procedural calls or distributed communication protocols. Many have been very deeply specified with thousands of pages of specifications. But in the end, the industry moved away from these protocols to a much looser concept. So loose it cannot even be deemed as a protocol, but rather REST is referred to as an architecture style. REST won not by being the most advanced or the most capable or the most efficient, but by being the easiest to get started and managed. If we look at history of ORS, at the beginning, which is 2011 and 2012-ish, it's likely to be an Apex feature or Apex listener. But after 3 years, Apex is no longer a requirement, meaning it becomes a standalone service and will provide you with different kind of deployment options. And with time going by, we launched a series of other features such as REST-enabled SQL, SQL Dev Web version, which I will show later on the demo. And today in 2021, we further improve the speed of ORS. We build a UI for data pump so you can easily migrate your database from one place to the other. We also embed database actions to all Oracle database, no matter where it is. All right, here is the demo time. Today I would like to show you how to create a Python application with a backend service hosted on ORS. And then, as usual, if you don't have an Oracle account yet, you will be able to sign up a free tier account here by clicking this. since I already have a Oracle Cloud account, I'll just click next. Here we go. This is our OCI console. And then if you click the hamburger menu on the top left, you will be able to see different kind of options. In this case, we're going to select autonomous database here. You can also find autonomous database under Oracle database or databases as well. But since it's a featured product, I'll just click here. Here we are on the autonomous database page. So first thing before we create a database is that you have to specify a compartment. Compartment is like a resource unit location in OCI. So here I created some. The first one is called management compartment for PaaS. The other is called orgs. And then if I click orgs, so as you can see here, I already have a autonomous database called orgs ADB provisioned. And then on the right-hand side, it says always free. So it does not charge at all. But you can always create an autonomous database by yourself. So the first thing you will need to specify a compartment, as I mentioned earlier. Then you will need to specify a display name and a database name. This is all customizable. And then we have different kind of options for our autonomous workloads. Data warehouse is more for analytics purpose or reporting purpose. Transaction processing is built for transaction workloads. For example, if you have a e-commerce website and then you're going to receive tremendous requests in a short time, we're able to do that for you. Also, we have JSON autonomous database as well. For example, you have a Mongo-like, or you are going to manage document collections, etc. And then also Apex as well. So in this use case, we're going to select data warehouse. Next is our database configuration. As you can see here, you will be able to swipe out this button so you don't get charged by Oracle at all. And then you can specify different kind of database versions. Here I just say 19C. And then since it's a always free layer, the OCPU and storage is a fixed amount that you cannot change at all. If it's not free, you will be able to check this box, which is auto scaling, meaning that when the server requests a tremendous request, from the client, we will be able to automatically scale up the OCPU and storage, for yourself. And then here you will need to input the password and confirm the password for your admin user. All right. So since I already have a autonomous database instance created, I'll just click this. So as you can see here, in order to access our Oracle REST data service, you will need to open database actions. This is basically the password that you specified previously when you're provisioning a database. Okay, so this is our Oracle REST data service page. The first thing I'm going to show you is how to import data from a CSV file. So if you click the SQL. So before we get it started, let me make a very fast introduction for our SQL Dev Web. So on the right-hand side, also on the top, you will be able to input any kind of SQL queries here to tuning, to manage your database queries. And also on the left-hand side, you will be able to see all those kind of tables and also the table structure as well, if you expand all those columns. On the bottom, if you input a SQL query on the worksheet, you will be able to see this query result here. And then also, for our first step, we're going to load data from a CSV file. In this use case, I'm going to click this, data loading. And then you can select files from your local machine. In this use case, I'm going to select CSV called dog data. So as you can see here, dog ID is my primary key for the table. And then we have dog name, dog owner, dog color, and age for the attributes. And then we can click next. All right. Since I already have a table called dog data, I'll just say dog data 1, and we can make dog ID the primary key by check the box. And then click next. So in this page, you will be able to see the SQLs that we are going to use, right? And then we can see all those kind of causal mappings from source to target, and then we can click finish. So on this left-hand side, you will be able to see the dog data 1 that we just provisioned. And then you can see all those kind of attributes that are related to this table. And the next page is, if it's the first time you provision this table, right, you will need to click, right-click the dog data 1 and then click REST enable. Enable. By clicking this enabling function, all those kind of ORs functionality are now embedded within your table. So for example, if you would like to use a curl command to query the data, you can just say copy. And then if we go to the OCI console, you want to test via a Cloud Shell. Cool. And if I type in the previous curl command that I copied from the SQL Dev webpage, and then enter, that's basically a get all function. And then you can see all those kind of data that we previously import into our database from a JSON preview. So next, we'll be adding a function to our database schema to simulate some business logic, right? So the first thing is that we're going to create a procedure. So what does that mean? Basically, we're going to create or place a procedure called return count1, and then the p input would be a bar chart. The output of our value would be a number. Basically, what it does is that it fetches data from our dog table, dog data 1, right? And then we're going to select the count number where the dog owner equals to p input. So for example, we have a dog owner called Lucy. She owns 2 dogs. In that case, we're going to return 2 if we input Lucy in this function. So here is our testing page. And by the way, you have to click this to store the procedure, before you testing these functionalities. Since I already have these functionalities run before this demo, so I'll just skip the actual run. But as a first-time user, you need to click this run script button. All right, and the next, as you can see here, we're going to run this function. We're going to specify the p input as Lucy, and then p output. And then if I click this, so as you can see here, the result is 2, because if you, for example, select everything from dog data, and then run this query, you can see there are 2 dogs owned by Lucy. So here is a very simple, business logic that we can implement using our PL SQL. And then in the next section, we have 2 tasks. First is that we are going to REST enable a custom SQL statement. The other is we're going to REST enable a business logic, which is a PL SQL procedure that we previously created. All right, so let's quit this SQL dev page. We click REST. Since it's my first time logging to this page, you can see all those kind of wizards and guidance. You can follow guidance. It will give an introduction of, all those kind of features and functionalities. All right. So the first thing of the REST enable is we have to create a module. Module is like a container for all of the APIs for this base URL. So the first thing we're going to do is that we're going to create a module. Module is like a container terminology. So the first thing we're going to do is we need to create a module. And then module basically is a container for your APIs where you can specify a base URL. And then we can create a module by clicking this button on the top right. So as you can see here, the first thing is you have to give a module name. And then if you look at the module that I previously created, com.oracle.livelab.api is a module name. The base path is /API/ as you can see here by default. But you can also customize everything by yourself. And then after you're done, you just click create. Since I already have a module created, I'll just take a look at this. All right. So basically, those are the only two parameters you will need to create a module. And then within module, you can create different kind of templates. So in my use case, I already created 4 different kind of HTTP endpoints for get, post, or delete. And then why don't we take a look at the get all? So as you can see here, this is the URL path as I specified. And then let's take a look of what it does. Basically, under this template, I just specify select everything from doc data, which is the doc table that we previously created. And then we can click run. As you can see here, this is the testing result. All right. And then we can also click edit. You can see this is a get methods. And in this box, you can specify items per page, meaning we're not going to overwhelm your browsers if you have like 1,000 or 2,000 records. And then next is, for example, we're going to do some select by owners. So as you can see here, it's a different kind of URL path. If we click this, you can see it's select everything from doc data where doc owner equals to this parameter. And this owner equals to the owner on the URL as well. That's basically how we create, all those kind of templates. And then next, I'm going to show you how to connect the PL SQL procedure that we created within SQL Dev Web to this. So if you click this, is logic, right? So if you take a look at the source, it's very, very low code, right? It's basically a single line of code. What it does is that basically we'll run a return count function that we previously declared in the SQL Dev Web. We're going to map the P input to the ID while we are going to map the P output to the output. And by the way, last but not least, you can always test all those kind of HTTP endpoints before you actually deploy your application. So for example, you're going to test this HTTP endpoints. You can say, all right, for example, still Lucy here. All right, so here you will be able to see a JSON style response where SQL commands equal to select everything from doc data where doc owner equals to Lucy. So next, I'm going to show you my Flask application, right? Basically, I specified 2 routes. And as you can see, the first function is called get doc information. This URL equals to select everything from the doc table, which is the get all here, right? I just copy and paste the entire thing from this place and paste it here, right? And then I just use the very traditional request, which is a get function, to call this and then get the data back, and then embed everything, which is a JSON, into the docs.html page. And next is a post, which is the biz logic, right? Basically, we're going to say if the request method equals to a post, and then we're going to fetch a data from the front end called owner name, right? And then we're going to, copy this biz logic API here, right? And then embed the owner name into the parameters. And then you can see we're going to redirect into our count.html page, and then embed all those count result and owner name here, so you can see the results. All right, so as you can see here, that's basically select everything from table. I actually have 7 rows, but if you remember, we specify in each page we can only show 5 results. So here we go. And then also you can type in Lucy here, still Lucy, and then click submit. And then it will return Lucy has 2 docs by running the BizLogic PL SQL procedure on the backend. And then next is press this to delete everything, which is a very dangerous button. And then so the next terminology or the next feature I'm going to tell you is how to protect our endpoints, because you don't want everyone to be able to manipulate with your API endpoints. So we're going to use OAuth to secure your website and your data. Let's go back to our words page. And then if you click security, roles, cool. We're going to create a role. And then in the role definition page, why don't we just call it now the role has been declared. And then next, we're going to grant the privilege to this role. And then if we click create privilege, all right, so in the label, we can just say, for example, live labs, REST privilege. And then we can give a name, Oracle.live labs privilege dot add. Is there any spelling errors? No. Okay. So next, we're going to specify the roles, which is the previous roles I created. This, and then protect modules would be this. And create. All right. Next, I'm going to create a OAuth client. Still, the name is always the most hard part. OAuth client, let's just say. And then the support URL would be HTTPS. Support email, I can just use my personal email, which is frank@gmail.com. And the rows would be the previous rows I created. All right, and then click create. Cool. So here we already created a role. We create a privilege and then assign the privilege to the module as well as the roles. And then we create a OAuth client. And then also let's just try this URL again. You can see right now the data is already protected. But don't worry, what if you want to access this? It's very easy as well, right? We can get a bearer token, which is like this. and then you can copy and paste the OAuth token into your Python application. So for example, as you can see here in my code, I already include the authorization into my headers, and I include the headers in both of my functions. And now if we rerun this application again, it's working. So back to our slides. Call to action. We provide a series of live workshops for you to try out, not only in the database world event, but also online. For example, if you're interested in the dev process for REST APIs and the CI/CD process, my colleague Brian is hosting a live workshop session called Oracle Database CI/CD for developers. That workshop will walk you through the database changes management via CI/CD using SQL and the OCI DevOps code repo. And if you're interested in learning more about ORs and test it, you are also more than welcome to register a free account on cloudoracle.com and provision our free tier database. Last but not least, if you have any follow-up questions, please don't hesitate to connect with me directly. My email is jiadong.chen@oracle.com. Thanks for listening.